going to show you two things in this screencast. I'm really going to show you how to set up some density problems, and I'm also going to show you how to do that on a Google Doc. So first couple questions I think you can answer. I'm going to show you the setup here for question number 1. So what I have here for question number 1 is just a simple problem. A block of aluminum occupies a volume of 15 milliliters and weighs 40.5 grams, and I want to know what its density is. So what I'm going to do is just type on this one, so D equals, and I'm going to do my mass, which is 40.5 grams divided by 15.0 milliliters. And that's all I need to do to set up that problem. Everything is in the units it has to be, so density is either grams per milliliter or grams per cubic centimeter. Now, when I pump that into my calculator, I get 2.7. But if you look at my numbers, you really should have 3 sig figs, so I need 2.70 grams per milliliter. Okay, and I'm done with that problem. That's all I need to do. Okay. For the next one, I'm going to skip down to question number 3. So what is the weight of the ethyl alcohol? And again, I really should have used mass, but I pulled this from another source. And we have a volume of 200 milliliters, so that's important. And I have a density of 0.789 grams per milliliter. So I have all of this information. So you can set this one up as an equation, but I'm going to show this as a bridge problem. So I'm going to go up here into my insert, and I'm going to insert a table. And I am just going to set that up with 3, and that's basically going to be my bridge problem. So I can shrink it up a little bit so it looks more like a bridge problem. And we can get fancy and we can delete the sides, but basically what I have here is my starting quantity, and I always want to start with the measurement, so I never start with density, and I want to find weight or mass, so this is going to be equal to my grams. Sorry, my computer's lagging a little bit. When you do video and other applications at the same time, sometimes it's a little bit of a lag time. And it looks like I put this in the middle of my problem. So the problem was 0.789 grams. I think I overloaded that. So I'm just going to type that down here. So try to make sure you're putting that at the end of your problem. Somehow I wrote it over my problem. So I have the milliliter part I need on the bottom. So the 0.789, that number part always goes with the gram. So I'm actually just going to copy that and do Control-C, and then I'm going to pop that up here. And then my milliliter part is going to go on the bottom. So remember that this slash line in between here is the same as the slash line here. Okay, and then when I put that into my calculator, okay, I get this really long number. Well, I lied. I get 157.8 grams, sorry. And if you look at my numbers, I have 200 milliliters, which is 4 sig figs, and 0.789, which is 3 sig figs. So I can only have 3, so 157.8 is going to round up to 158 grams. Okay. Now, if you really want to get fancy, and I don't care that you do this, but if you want it to look more like a bridge problem, what I'm doing is going around and I'm selecting all of the edges of the boxes. And again, this can get a little on the problematic side, but I'm holding my Control key down, so when you want to select more than one thing, you need to hit Control. That's similar in spreadsheets as well. And for some reason, it's not liking that. And then I'm going to go up to my menu, and I'm going to go to white. So you'll see that that took out the majority of them. And I don't care if you leave the boxes, that's fine. But if you want to clean it up and make it look like a true bridge problem, that's fine. But I have no problem with you leaving them as the bridge problem. Okay, for question number 4, I have a rectangular block of copper weighing 1896 grams. So again, I have the mass. The dimensions of my block are 8.4 centimeters. So that's my length, 5.5 centimeters, which is my width, and 4.6 centimeters, which is my height. So I'm going to find density. So it's a little different than the one we had up top where we're just dividing by this. So I am going to set this one up sort of as a little bridge problem. So I'm going to start this one by, again, going up to Insert, and I'm going to start with my table. And again, I'm going to start with something that looks a little bit longer than what my normal table is. So for density, I need mass on the top. So I could almost go out here to the end and say, okay, if I'm looking for density, I want units of grams. And since I have these in dimensions, I could go over centimeters cubed. So that can help you with doing your problem as well. If you want to highlight, you can go up to Format, Text, highlight and superscript. Again, I'm not really caring under these circumstances if we don't have that. So that tells me that I have to have the gram part on the top. So these are all measurements. The grams are measurement, and the 8.4s, 5.5, all those centimeters. So those need to go on the bottom. So measurements can stand alone. They don't have to have anything with them. So what I'm going to show you with this is, what if I need another box? So I'm going to go here, and I'm going to go into my right click, and I'm going to insert a column left. Okay, and you'll now see I have another box. So measurements or volumes go on the bottom, so I'm going to put each one of those on the bottom. Okay, and then in my calculator, I'm going to enter 1896. I'm going to do divided by 8.4, divided by 5.5, and divided by 4.6 to get my final answer. So again, this 8.4 centimeters times 5.5 can also be calculated separately as volume. I just like putting it all in one place. So there's nothing up here because these are not conversion factors, they're measurements, so they stand by themselves. So it's not the only way to set this one up, but I wanted to show you that. So I'm ready to calculate. To 2 sig figs, that would give me 8.9 grams per cubic centimeter. Okay, so that's how you use or create factor label problem solving in a Google Doc. Okay, question 5 has some extra numbers. We have a flask that weighs 345.8 grams, and it's filled with 225 milliliters of carbon tetrachloride. The weight of the flask in carbon tetrachloride is found to be 703.55 grams. So I have two masses here. So you might remember from doing some of your labs that you need to subtract. So I can do my subtraction just this way. Oops. Sorry, my one key is not working. So when I subtract those two, I get 357.8 grams. Okay, now this one I have the mass and I have the volume, so I'm going to just do the easy simple setup. Again, you could use a bridge problem for that, but I am just going to set this one up because it's a pretty simple one. So there's 357.8 grams is my mass, divided my volume of 225 milliliters, and I just divide those out, each of those. So we have 4 sig figs divided by 3 sig figs, so that gives me 3 in my final answer. So typically, if you have two quantities of the same unit, you probably have to subtract them. So think about how we collected data in lab.